Dear students, we are going to find out, discuss another important theorem. The theorem says all iterated kernels of symmetric kernels are also symmetric. Iterated kernels, as you know already, we have solved so many problems based on the iterated kernel to get the resultant kernels. Now, all the iterated kernels of symmetric kernels are also symmetric. We need to find out that k of x comma t must be equal to k of t comma x. That's a symmetric kernel. So we'll try to find out now. The iterated kernel is defined as k1 of x comma t. Now these are iterated kernels like k1 of x comma t equal to k of x comma t, k2 of x comma t equal to integral x to t k of x comma z, and k1 of z comma t dz. That already we know the formula. According to that formula, now we are writing as kn of x comma t, that is integral a to b k of x comma z1 k of n minus 1 z1 comma t dz. This is the nth term, that is nth term we have found. We have taken nth term. Now we'll take k of x comma z1 as it is. Now this one will take the next previous term, that is a to b k of z1 comma z2 k n minus 2 z2 comma t dz2 dz1. dz1 is the last term, so before that dz2 kz1 comma z2 k n minus 1 z2 comma t. You have to understand very much, you have to understand very clearly this, the previous term we have written. Now we'll take this term outside, means k of x comma z1 k of z comma z2 we are writing as integral a to b twice, and we'll take this term previous to this term. We'll try to find out k of z2 comma z3 k n minus 3. We'll take k n minus 3 z3 comma t 3z3 z2 and the t z1. So that's the previous term. Now this one will be going to this side again. Now again the previous term, and so on. If you take, you'll be getting the kzn minus 1 term into t, and that is you'll be getting as dzn minus 1 dzn minus 2 dz2 and dz1. This is what we got by taking all the previous values. Now we'll try to find out now this is about the kn of x comma t. We got as like this. Now we'll try to find out kn of t comma x as well. So t comma x, kn of t comma x, how it will be kn of t comma x. Now integral a to b and integral a to b, wherever x is there we'll put t and t comma z1. Previously we have written x comma z1. Now we'll take t comma z1. So this is t comma z1 and k of z1 comma z2 z2 comma z3 zn minus 1 comma x into dzn minus 1 dzn minus 2 dz1. Then that is equal to, now this I am writing because it is symmetric. I am writing is k of z1 comma t z1 comma t z2 comma z1, then and so on x comma zn minus 1, because it is symmetric. So we'll take the first term to this side, dz1 into z2 and so on dzn minus 1, because since k of x comma t is symmetric, it is given. So therefore integral a to b k of now x comma zn minus 1. Now we'll take first term like this term. The previous term is there, will be there, that I'll write here zn minus 1 zn minus 2, and the other previous one and so on. You will get as this term and this term, such that this is as it is, and write as it is. You should understand once again. This term is there. No, this first I'll write this term previous to this term, then and so on this term and this term, and this will be same as it is. Now we'll substitute zn minus 1 zn minus 2 and so on. For zn minus 1 we'll write z1, zn minus 2 we'll write z2 and so on. So we'll substituting zn minus 1 zn minus 2 z2 and z1. For zn minus 1 is z1 z2 and so on. z2 I'll write as zn minus 2, z1 write zn minus 1. So kn of t comma x we got as a to b k of x comma z1, this one z1, this is z1 comma z2, this is zn minus 1 comma t, the last term last term we have written, last term. Z1 means Zn minus 1 t, and dz1, dz2 and so on, gzn minus 1 as it is. So this entire term is nothing but resembles the first one, k z x comma z1, z1 comma z2, z2 comma z3 and so on, zn minus 1 comma t. Now this is the term which is nothing but kn of x comma t. So therefore this is both are equal. So therefore kn of t comma x is equal to kn of x comma t. Thus kernel kn of x comma t is also symmetric. Hence by the induction every kernel of symmetric kernel is always symmetric. So this is an important question. It gives 4 marks. So once again, all iterated kernels of symmetric kernel also symmetric. Now we need to take k1 of x comma t, k of x comma t. Already we have taken some formulas. Based on the iterated kernel we have solved resolvent kernels. So same formula will take nth term and will try to simplify in such a way that you will get an equation, a big equation you will get in the form of like this, n minus 1. Next term will take this one outside, and this term is there, no, kn minus 1, like kn x comma t is whole thing, no, integral a to b k of x comma z1, k of n minus 1 comma z1. In the same way, in the place of n minus 1 will take, in the place of n will take n minus 1, n minus 1 will be here. So therefore you will be getting as z1 comma z2, z1 comma z2. This is k n minus 1, in the place of n minus 1. So n minus 1 means n minus 2, z2 comma t. So dz1 means dz2 into z1. In the same manner whole thing will do. So this may be equal to kn of t comma x, that we are going to find out according to this procedure. Thank you.